Welcome to this beginner-friendly tutorial on creating a wave-based enemy spawner in Unity 3D using C# coroutines. Coroutines are powerful functions in Unity that allow you to pause execution and resume later, crucial for time-based operations without freezing your game. Wave spawning involves generating multiple enemies in a structured sequence, often with increasing difficulty to challenge players. Basic enemy AI will dictate how your enemies move and interact within the game world, providing a dynamic experience. We'll also touch upon user interface elements to display important game information like the current wave number and enemy count. First, let's set up our project. Create a new Unity project and name it Wave Spawner Tutorial to keep things organized. Import any necessary assets, such as enemy models, basic environment props, and non-copyrighted background music to enrich your game. Next, we'll create our enemy. Start by making a simple enemy prefab, perhaps a cube or a basic 3D model, and add a rigid body and collider for physics interactions. Now, let's write the C# script for our enemy. This script will manage its basic movement, like moving towards the player and a simple health system. The enemy script defines a public speed variable, a transform target for the player, and a rigid body RB for physics. In Start, we get the rigid body component and find a player game object using its tag to set the target. The fixed update method handles movement. If a target exists, it calculates a move direction and uses RB to move position to move the enemy. Next, create an empty game object in your scene. Name it Spawner, and this object will control all enemy spawning logic. Create a new C# script called Spawner and attach it to your Spawner game object. This script will manage the entire wave spawning process. Coroutines in Unity are declared with the IEnumerator return type and use yield return to pause execution, allowing for timed events. The wait for seconds command is crucial for pausing a coroutine for a specified duration, controlling spawn rates and wave intervals effectively. Let's define the variables for our spawner script. We need an enemy prefab, a spawn point, wave size, wave interval, and spawn interval. We also need current wave to track progress and a coroutine wave coroutine to manage the running coroutine. The start wave method increments the current wave number and then initiates the spawn wave coroutine. The spawn wave coroutine uses a for loop to instantiate enemies at the spawn point. Inside the loop, yield return new wait for seconds controls the rate at which each enemy is spawned. After all enemies in a wave are spawned, yield return new wait for seconds, pauses before the next wave begins. Finally, start wave is called again at the end of spawn wave to recursively start the next wave, creating a continuous cycle. In the start method of our spawner script, we simply call start wave to kick off the very first wave when the game begins. Let's review the complete enemy script in Visual Studio, ensuring every part is clear and understandable. Now, let's examine the spawner script in Visual Studio, walking through each variable and coroutine we've implemented. When debugging, use Unity's debug log to print messages to the console, helping you track variable values and execution flow. Common mistakes include forgetting to assign prefabs or spawn points in the inspector, leading to null reference errors.
In the Unity editor, assign your enemy prefab and spawn point variables to the spawner script in the inspector.
Adjust wave size, wave interval, and spawn interval directly in the inspector to fine-tune your wave mechanics without changing code. Run the game to see your enemies spawn in waves. Observe how they appear at the designated spawn point and move according to their AI. As enemies are instantiated, they will appear in the hierarchy view, confirming that your spawner is working correctly. Always add comments to your code. They explain complex logic and make your script easier to understand for yourself and others. Use clear and descriptive variable names. This practice significantly improves code readability and maintainability. For optimization, avoid heavy operations within a single frame. Use yield return null to allow other tasks to run, preventing performance bottlenecks. To increase difficulty, increment the wave size variable with each new wave, sending more enemies at the player. Introduce different types of enemies with varying health and speed to add strategic depth to your game. Scale enemy health and damage based on the wave number, making later waves progressively harder. For randomization, Use multiple spawn points and randomly select one for each enemy, making enemy appearances less predictable. Randomly select different enemy prefabs to spawn, introducing variety and keeping players engaged. Integrate UI elements to display the current wave number prominently on the screen. Also, display the number of enemies remaining in the current wave, providing players with crucial tactical information. Finally, show a clear message when a wave is completed, celebrating the player's progress and preparing them for the next challenge. By following these steps, you can create a robust and engaging wave-based enemy spawner in Unity 3D. Coroutines are fundamental for managing timed events, making your game mechanics smooth and responsive. Experiment with different wave configurations and enemy behaviors to create unique and challenging gameplay experiences. Thank you for watching this tutorial. We hope you found it helpful for your Unity game development journey.